Welcome to tusknet. Tusknet is a collaborative data training platform based on the decentralized storage platform Walrus, and it is a implementation of federated learning. And if you guys don't know about federated learning, you can read our docs for what is federated learning. So basically, federated learning is a technique in which some user can upload his or her model, and the model can be used and can be trained by different users on their different data sets, which would be like a distributed data set overall. And through the distributed data set, each data set of each user is cryptographically encrypted and is private, and the weights and biases are cryptographically calculated, and then their decryption happens and the model is trained on that. So basically, now moving on, I will show you how the app works. This was all about the introduction to FL. You guys can have a read here in the git book. This is welcome to tusknet. You can see here, you can go to the deep dive section. You can read about all the cryptography, how Walrus was integrated, and how on-chain stuff and all other. So let me show you an example of our app. So first of all, you can see, let us open the app now. As I go to get started, you can see the MetaMask opens up, and I connect my MetaMask here. And as I connect my MetaMask, I can go to the get started button. Now as I go to get started, you can see this is my address 0858f, this and this is my Sepolia balance. So now you can see that there are two options: a publisher and a trainer. A publisher is the one who publishes the model, and the trainer is the one who will train the model, who will provide the data set. And so basically now I can add a new model here. So for adding a new model, you can see that I have to add a file. So basically now I will add a trial model, that I have a linear regression model that I have written. So moving here, so going, so now basically I go to next, and now I have to enter a title. I will enter FL. How many epochs is basically rounds. I want one. And how many ETH I want? 0.01 staked ETH. Stake ETH is basically the amount of ETH that the trainer has to stake, because the trainer might be malicious, and if a malicious activity is recognized, then the slashing will be done accordingly. So now moving next, you can see that your model is in the draft section. You can edit it, or if you want, you can publish it for training. So now I can move my model from drafts to published section. Now in the published section, you can see my model is here. And now I will like to open another profile. Let me open this profile. Okay, I was already logged in here, so let me reload it once. So you can see that I am here. It is okay. So if I go to the trainer section, it is a different wallet ID of mine. Now if I go to the trainer section, you can see that in the available section, this is the model that I had uploaded. So now you can see that I can click on the start training button. So start training button will be simply for training the dataset, and as I click on the start training button, and I would have the code on my local machine, then what will happen is, in the model directory, a model.py file will be created, and now for that, in the model.py file, my model will be uploaded. And now I'm providing the data, which will be sent to the dataset folder, and from that it would be fetched, and the model would be trained accordingly. Now if I click on open, you can see that I have opened here, and this is the stake, and this is choose file. And currently the stake, you can see the wallet is not coming, because I have directly used the new ethers.wallet from ethers.js, and it directly cuts the tokens, and it does not like open the wallet for it. So now if I click on the stake button, you can see that I have clicked on the stake button. And now if I go on the backend, here you can see that it was server is running, and you can see multiplied prediction. What is multiplied prediction? Multiplied prediction is basically that in my linear regression model, the estimated value was 30, but mine was coming 29.89. So now I multiplied it by 100, so that it is a bit it is it is calibrated a bit for the usage. So salt is the random value for the Peterson commitment, and encrypted cost is the final encrypted value. Now our encryption.txt file will be created, which is our commitment file, and it would be uploaded to Walrus as well. And as the encrypted file is uploaded to Walrus, you can see that that file now can be fetched by the model publisher, and he can verify the commitment schemes on commitment schemes. Now going back to this profile, you can see that the training has started, and now if I go to this button, you can see that this is the aggregator button, contributors on your model, and you can see that I can start the aggregate button. Clicking on the aggregate button will start my aggregation. So clicking on aggregate, and you can see that the aggregating button is showing. And if I open my terminal here, terminals, yes, one thing I missed was that when I had the walrus.js, when I had uploaded the model, so the blob ID is also available, and the transaction that the blob storage ID contract has made was also there. I had forgotten to show it to you guys. So now basically you can see this was the client node, and here it was running. Now blob ID is there, a transaction has been successfully done here, and this transaction was basically for the aggregation part, and you can see that I am receiving a loss value from here, that is 29.890. So as you could see that the value was approximately 29.89, and from the aggregation, as currently only one person was there, it is coming this. But you can see that if you could read the code, it was simply that if there would be one another user, then the federated average would be taken and the value would be near about this only. So thanks a lot guys. Hope you liked my project.